a little eye-opening, especially when you have this as your clientele, and you're trying to make sure that who you have is ready. This is not by any means. Don't misinterpret what's being said, but put yourself into my position for a second. So this happened with the kids coming in from Algebra 2, or into Algebra 2. I sat there and looked, and there was this huge discrepancy between their quarter grades and their average. We're talking some kids in excess of 20 points. There was one student, I thought it was a typo. They had a 4-quarter average, 4 quarters, of 94. They sat and took the Geo Reach, and what did they get? 68. Okay? Now, put yourself, and they're in Algebra 2 Enriched this year, and I feel bad for that student. Because whatever was happening previously, whatever they were measuring, I can assure you, if you know even 90% of the material, do you remember what that curve is on the Geo Reach? Because remember, it's scaled back. 39% goes to 65. Let's hope the medical boards don't have that curve. Can you imagine? You go in, did you just have your teeth out, your wisdom teeth? Imagine right before, who's in here has got their wisdom teeth out? Nice and high. Okay. Imagine right before they gas you, right? The doctor is sitting there, and the nurse, did they gas you? Okay, so they have a little mask and everything, they come over and they go, now, and did they call you Hannah too, or did they just say Hannah? Just Hannah, all right. It'd be kind of awkward, right? I'll call you. So they come over and they go, Hannah, don't you worry. This doctor is outstanding. They got, and they passed their medical boards because the curve turned to 39% to a 65. And they throw the mask on, and you pass out, right? You'd have an accident in your pants. You'd be so terrified as to what this monster was doing to you. But then I sit there and I feel for the kids because they're trying to do the work, and no one, and there's a certain part of it where, someone needs to be a bad mommy and say, no, that's not how you do it, and you actually have to perform. Just like if you, went through in, you do football, for sure, you're right? Okay. If we played, let's say, East Rochester / Gananda 3 times during the year, and then we played 2 against Williamson, and then we played 1 against Wellsville, all right? You think you were pretty darn good, right? And then you go out there pretty arrogant, and now you're going to play Pittsburgh Sutherland. And someone's going to tackle you, and your body's going to rip in half, okay? You're going in thinking you are better than you are. My goal is the exact opposite, as any of you that had me at least for Algebra 2 know. I play whack-a-mole with you. If the grades get too high, I make it harder. You need to understand, and by the way, who raised your hand if I had you for Algebra 2? Let's ask this. Who in here had higher region scores than their 4 quarters? Raise your hand if that was you. Okay? Thank you. I changed it to make it reflective of it because you showed me you were proficient. I don't want that to happen here. I want you to be, listen, you need to know what you're facing, period. I'd rather be the one here that knocks you down 100 times and you go, well, I'll actually learn this, than thinking you're one thing and going into the other. I even talked to one student who cried on the, because these kids, keep in mind, the enriched kids, some of you are on that track. You can all think of somebody who's so obsessed with what their grade is that they equate their self-worth to their grade. There was a person that I spoke with who cried during the exam because, and it was universal, they didn't know how to do the 6-pointer at the end of the test. I felt for that student. Why? They were thinking that they could get a 100. Were they equipped to get a 100? Yes or no?
No.
No. You have to be real with yourself. If you don't know your derivative rules, are you going to be able to take an antiderivative?
No.
No. You're right. There's always an exception. Most of you won't. What I need you to understand is, and I love, because I'll have kids come in and we go over the mistakes on their exam. And it always makes me laugh because you get so down, you're obsessed and fixated on this number. I'll give you all 100s. And by the way, what's the beautiful part of giving everyone 90s? Guess what you never have to hear from them? Mom and Dad think I'm wonderful. Outstanding. Oh, they gave my child 100 and they watch videos every day. What's wrong with you people? I sit here and look every day. Not only do I do the math, I type it up to make sure I don't screw up with you. You think it's easy to type math? No. It takes forever. And all my fonts, Christmas lights,
Candy canes,
hearts, candy canes,
frosty tags.
Frosty! I even cared so much about you. I was thinking I was going to spend $28. 30.
Spend 60.
60 bucks?
Get a load of
People
that.
cost me. I didn't even spend $60 on my nephew. Well, I'm a sucker. I'm a sucker. But listen, if you put the work in, you'll get it out. But let's be honest with each other. I don't want you to have an unreal expectation, period. And you need to understand that even these questions in this situation is not as intense as what you're going to feel if you're signed up and you step into that AP room. You already know. Who's here has taken an AP before? Is it a nerve-wracking experience? It should be. It should be. That's the goal. You don't want a doctor working in the ER and someone comes in with a gunshot wound and the person panics. You actually would know. You guys, do you do ER rotation? Anything in the ER? ER right now? Did you do one or not? Is that a hectic scene? Do you see people panic? Do you see, let's say it this way, have you ever seen a doctor panic in that situation? No. Have you seen the families panic? It's scary as hell. And it's even scarier if the doctors don't know what they're doing. You all need to know what you're doing. Period. Because that exam is a pressure cooker. It really, really is. Get used to the pressure now, and don't go in with false expectations. Take a look at what we have to start off. Question 1, this is a complicated question. It says oil slick is leaking from a pipeline, surface of a lake forms an oil slick, volume increases at a constant rate of 2,000 cubic centimeters per minute. The oil slick takes the form of a right circular cylinder with both its radius and its height changing with time. Note the volume of a right cylinder with the radius R and H is given by that. Now, was there a lot there? Absolutely. And by the way, the thing that was interesting, does anybody know what happened in 2009 that made, I think it was maybe 2009 or 2010, that made this all the more there you go, in the Gulf. So yes, you need to know calculus. Looking at what's there. Let's take inventory of everything we know. Hands up, please, if you can tell me something we know from this that we can pull out before we go and answer out A. What's something that we know? What? What else? That's the only thing we got? Really? The radius is 100 at this point. What else? Okay. Now, this particular question, I think we took inventory adequately of everything that's there. It says, at the instant that the radius of the oil slick is 100 centimeters and the height is 0.5, the radius is increasing at that rate. At this instant, what's the rate of change? I'm going to start off. What do you need to do to begin? What's the first thing that you all are going to put on your paper? What? What's that? Not yet. I didn't show what yet. You could give a picture. What? The equation itself. Let's start off with what the volume is. Now, this is one thing that some of you, your way of getting there might be slightly different than mine, but both are viable. Looking at what we have to begin with, if this is what we're starting with, now we need to take the derivative of this. Because we're looking to try to find what's the rate of change of the height. I'm trying to find the rate of change of the height. Now, I don't have a way to get this down into just two variables. It's not going to matter, because we've got enough to fill everything in. I'm going to start off in. Now, what I did is I viewed it as this breakdown. So, when I took my derivative, and if there's a multiplier, you can literally pull the multiplier out and take the derivative. So, looking at what we have here, This is going to require us to apply what rule? Product rule. So I'd say dV dt is equal to, now I took pi and pulled it out. What is the derivative of this going to look like when I take the product rule? What?
R squared dH dt plus h times 2r dr over dt.
What did you do next? And so help me God, you better write neatly on that AP. I don't want to, because if it was me looking at that and I didn't know you, I'd say this person is getting assaulted while they're writing the exam, and or they did it during an earthquake, or on a plane while it was landing. Possibly all three. Yep, we make our replacements in. So I say dV dt is 2,000. We know pi is still going to be the same. What is the r in this case? 100. So 100 squared. We don't know the dH dt. That's what we're solving. What is the h in this case? What's our h? 0.5 times 2 times the r times dr, which is 2.5. Now, I don't care how you do it, solve for this. And actually, by the way, this shows up. Go and make, I love it. If you're not logged into your calculator, what are you doing? Do it now. Because I'm going to show you a little trick that they didn't show you before. If the calculator is available, this is something that I didn't even know wasn't even turned off for the reach. Go in right now, please. Get yourself a new document. Get yourself a new document. Go in and hit Menu 3-1. So for algebra and then numeric solver. Press Enter. Now, input that equation, but instead of dH dt, put in just an x. Plug in the equation. Stop waiting, start typing. No, plug the equation in. So what's the first thing we're typing in? 2,000. It's the same one that you all have on your paper. And if you weren't, that means we weren't keeping up with what we need to. 2,000 is equal to pi, parentheses, let's go. Pick up the pace. Just replace the dH dt, whatever you're solving for, like with an x. Okay? So plug in. Person got it? Let's see. Now, I just want to make one thing clear. I don't think this will affect the outcome, but whomever this is, go back please here and put a time sign in between. Whomever this is, go back and put a times in between there and put one here just so it's clear. If there's multiplication, don't shortcut it. So put the dot and then the dot. After you've input all of it, put a comma x. After the equation has been input, put a comma x. What?
How did you get that?
Hit Menu 3-1. Put comma x and enter. What did it do? What did it just do? If you're not getting it, you literally, all you have to do is look up here. Whomever this is, typed it in absolutely fine. If you didn't type this in, you're not getting the right answer, obviously. And then you've probably got big picture issues. Look at what's up there. Don't say the calculator's broken. Is this stuff there? Go line by line, term by term. It will solve it out if you put in an equation, comma x. You could distribute. I don't care how you get the answer. This is one way to do it. So what is your answer going to be? Rounded appropriately? What? Because in this we go out three significant figures, 0.038 or 39. 38 is stopping, 39 is rounding. And put the units on it. Questions on that? Now, and again, you have to know how to use the calculator. It's not some adversary that's there for you. Sometimes you just need, some of you think you have to do all this work. Sometimes you just type stuff in if the calculator is available, period. Let's take a look at question B. The recovery on this, someone shows up and starts removing the oil. The rate at which the oil is removed is that. Notice it tells us something, well, a lot of you are going to screw it up. The rate at which the oil is removed is that, where T is the time in minutes since the device began working. Oil continues to leak at a rate of 2,000 per minute. Find the time when the oil slick reaches its maximum volume. How can I figure out when this is going to reach its maximum volume?
We equate it off as 2,000 T minus 400 times radical T, and then take a derivative of that.
Now, I'm going to say he's incorrect because of one thing.
You have to take the derivative first before you plug in at 2,000.
You're missing something that was given to you. You're missing one thing that's in there. Notice the rate that it's removed is that. What does this represent then? That's the rate that it's going away. This is the rate. You don't need to take the derivative to find the rate of change of it. This is the rate. And what's the rate that it's going in? 2,000. So you don't need to take the derivative. You gave us out an equation. Some of you might have gotten to the right answer the wrong way. The change in the volume is equal to how much is constantly coming in, which is what? How much is constantly coming in? And how much is constantly getting pulled out. So the rate that it's going in is 2,000. The rate that it's coming out is the R. So how do you figure out how much is there? $2,000 minus the R, and then we need to figure out when that is equal to 0. What do we do to figure out when that's equal to 0? Hands up, please, if you can tell me. Oh my. Seriously? The equation's not the tough part, and I'm guessing those who told me this already solved this out. What?
Add the 400 and square both sides.
So you get T is equal to what? Seriously? You can't solve that?
25.
Okay. Now, justify the answer. What's the justification for this? Well, plug in a value, go into your calculators, plug this in, and let's test some values to see what happens. By the way, you're not going to plug in 25. Why would you not plug in 25?
0.
That's when it's 0. Plug in a value that's 20, let's say. Go in, and again, some of us don't get this part of the calculator. Go in and plug in the equation, then put a bar, R or T or whatever it is, equals. So 400 radical, because we're going to do it more than once, radical x, and then do a bar, and then do x equals 20. That plugs it in. So now go back and change it. Try it at 30 now and watch the difference. What's the difference? What happened between those two? What? It changes sign. The rate changes sign. This means that here, this is added volume, this is lost volume. Do you understand? Yes or no?
Yes.
Okay. Here's the point breakdown from the reach. Now, you needed to give a justification. This person, when they went through on this student sample, they went through and said this, checking the values before and after. The volume, or the change, is going to be greater than 0 for numbers between 0 and 25. And the volume is going to be less than 0, change in volume, is going to be less than 0 for greater than 25. So it reaches its maximum volume at 25 after the device begins working, period. Everyone in here should be able to do that, without exception. Is it difficult? Absolutely. You don't need more than this, though. And here's what the College Board said. Same exact thing. This summary needs to be there. Could you use a sign chart? Sure. Can you use sentences? Yes. The problem that some of you have is you give sign charts and then you don't label it. So it's like you're making some sort of smiley face out of pluses and minuses. There's no way to interpret that. You've got to know how to do these. First part, everyone in here should receive a minimum of 4 points. Minimum of 4 out of 9. And if there's 6 of those questions, what's 4 times 6? 24. You need about 46 points to get yourself a 3. You're halfway there if you can pull 4s on all the 3 responses. And that means you need 20. That means you need 10 multiple choices right. Got it? Keep these in a place and go back and do them. Cover your work and go back and do them. If you're serious about being successful, that's what it takes. If you don't know how to answer it after we've gone through and explained it, then you need to do more review. Okay? Now, let's work ourselves over. Go over, please, to your note packets. We're going to skip page 3. They wanted to do more of the same garbage. We can pick up another day. Which means we have more time to review for the AP at the end. I'll take it. Looking at what's there, this is a calculator active question that you don't need the calculator to do. So we're going to skip day 3. Yeah, I mean, I don't know. Yeah, we did these other things. I don't know. Taking a look at what's here, answer out, let's say this. We'll start off, this is what we're at, and this is the figure we're working with. $2,000 AP, calculator active. 2 runners, A and B, run on a track, straight track for 10 seconds. The graph above, which consists of 2 line segments, shows the velocity of the runner. The other guy is given by the equation. Now, for question A, it says find the velocity of runner A and the velocity of runner B at time equals 2 seconds. How are we going to determine what those different velocities are? Well, actually, let's say this. You guys, how would you go through and answer out? I guess there's more than one way we can do it. How would you answer out, well, let's say this. To figure out the velocity of runner A, what would you have to do? Okay, find the slope of what? And what's that slope going to be? I don't want to ruin it. You should easily be able to tell what that is. It starts at the origin and goes through that point. What's the slope? Seriously? Yeah. Because you go to the left. That's what the slope is. Now, we need to figure out what this value here is going to be. Keep in mind, runner A comes from the graph, runner B comes from the equation. So, which velocity do you want to go through and find? Evan, which one? Do you want to find runner A or runner B's velocity? You get to pick. Runner A. So we need to find what the y value is at 2 of that. Who can give me who can tell me how I can figure out what that value is at 2? You need to find the y value at 2. How would you find it? What's the equation line going to be? Y equals 10 over 3x. Okay? And then what do? Plug in a 2, right? What are you going to get? And it's meters per second. Molly, how can you figure out the velocity of runner B at 2 seconds? By the way, make sure you label them. And when you do AP questions, 3 responses like this, I ask that you partition your work, meaning draw a little line to separate that out. Molly, how would you find the velocity of runner B at 2 seconds? Which equation? There you go. Now I know some of us need a calculator to do that. Hannah 1, let us know what you get. Questions on that? Answer question B now. Find the acceleration and the acceleration of v at 2. Now, if that graph gives you the velocity, to figure out how to get the acceleration, how does the acceleration relate to velocity? Who remembers? You've done enough to answer this. Adam? It's the derivative of it. So, which one do you want to take the derivative of first, Adam? Okay. What is the well, what would you go through and get? I'll say we're to here. Let me just double check. So we've established this right now. So we need to figure out what the derivative would be at 2. Hands up, please, if you can tell me what the derivative 2 is going to be. Really? 3? 4? What's your derivative at 2 going to be? Thomas? No? Close. That's the value. You just gave me what the velocity was there. I need the acceleration there. How'd you get it as 10 over 3? Look at what the equation is. What equation models this? Y equals 10 thirds x. Take the derivative of that. What's the derivative of 10 thirds x going to be? 10 thirds. Now, this is when you need to know how to use your calculator. Who can answer what we'd have to do for the second question? Or sorry, to finish out B, because we answered one part of it. Yeah. Give me more. And once you take that derivative, what do you do then? Now, if you did this the long way, what rule would you have to use to take your derivative? Hands up, please. Davey? Is this calculator active, yes or no? Why are you wasting time if you're doing the quotient rule right now? You can plug it in exactly as it looks. So go in right now, please. Plug it in exactly as it looks. Who is this? Molly, thank you. Let's see, we pick on new people. Who's not working? We'll make them our presenter. No, we just went back to Molly. Not presenter. Let's refresh. We'll pick whoever isn't plugging it in. We'll pick whoever isn't plugging it in. Oh. Similar to the person. We're having a communication error. Bring your calculator up.
Bring her out.
I didn't stutter. Interesting. Okay. You got the right thing.
No.
Shh. Will it link to anyone? Uh-oh. Is the error on me?
I don't know.
You have the error.
Yeah.
Okay. What's our answer going to be?
72 before you just
Close. Not right.
per second squared.
Meters per second squared. So this is what needs to be down on your paper. Now, you can go right to that. This is doing out actual algebra as opposed to mimicking. If you don't go through and input exactly what the calculator has down there, input it so it looks like what the calculator has down. If you want points, you either do it out the long way or you're writing this right here. This right here. Put the bar, and when you do it, just make the x as a subscript, though. Make it, put a bar, and then do x equals 2 underneath it as a subscript, not the same size, and you get 72 over 49. Yes, your notation does matter. Do we have questions on either of those? Now, the next part of this. For C, find the distance run by runner A and the distance by runner B from 0 to 10 seconds. How would we find the distance? Let's say this. Adam, which one do you want to find the distance run by? Do you want to find the distance run by runner A or runner B? Okay. How would you figure out the distance run by runner B? Nope. Because that's giving you only acceleration. You've got to go in the opposite direction. Antiderivative, give me more. No. You didn't pay attention. Who can tell me what we have to do? He said, what did you say? Louder. Okay. You got to give me more, though. What? On the interval 0 to 10. Now, so let's go through. You go into your calculator and you write this. It's under calculus. Find it, evaluate it, and do it. And you're going to tell me what you go through and get. Catherine will say it nice and loud once she's got it. How do you do what? Hang on. Let's see. Who is this? Represent a show. Where are you, Ben? No. McCarthy, where are you? Yeah, now you just plug stuff in. The integral for what to what? What's the lower bound and what's the upper bound? Okay? And you're collecting the area from 0 to 10 of what? Who can tell me what we got to collect the area from 0 to 10 of? Jack? Yeah. Now, you could use T or X, that's fine. You just make sure you stay in X there, not a T, and press enter. It's just an X. There you go. Now, what's your answer going to be? If this isn't on your paper, it's incorrect. Take a look now at the next one. Now, baby, how are you going to find out the distance run by runner A? There you go. You were answering A before. We were talking about who? B. All right, loves, go through. I don't care how you do it. Figure the area out. And I'm sure you need a calculator for it. Where's Sam? Took the day off. I'm outraged. Leah? Do you think Sam's listening to us right now? I love that because I love to, once in a while I'll talk about the people when they miss. I bet you Jake will watch. Noah probably won't. Sam, I don't know. It's 50-50. I'll say this. If Sam watches, I'll tell Sam right now, send me an email. Say, I watched this, and that's it. And we'll give Sam 5 points. 5 points. You all get 10s. And let's say this. And Jake and Noah, if you are watching, you send an email that says, did Sam send you an email? And we'll reply to that. We'll see how many we get. And don't tell them. Don't ruin the secret. Got it? See? Now, what value did we get, Jack? What'd you say it was? There you go. Yeah. I don't care how you break it down. I use trapezoids. Questions on that? Next one up. When we do this question now, these ones I always get interested by because these are actual AP questions. No calculator. And boy, this is so easy to do. It says we know that the area from B to A of the function underneath f of x is equal to 2 times A, 2 times B plus A. That's the area under the curve. That's what that integral is equal to. Now, figure out what this would give us. The function shifted up 5. Now, let's process what's going on. We're taking the f of x values and adding 5 to them. Here's what we need to go through and view this as. Separate this out into 2 integrals, or 2 antiderivatives, however you want to view it. One of this and one of that, because you can separate those out. So, you're going to rewrite this as 2 separate integrals. This can be rewritten as this. You can rewrite that integral accordingly. Now, you already know the value of one of those. Which one what can we do to work towards an answer? I guess I'll leave it open-ended. What can we do from here, Kanji, to work towards an answer? So this is going to go to A plus 2B over here. Can tell me what this is going to go to. Think about what it's asking you, because this again should be you're making it too hard. Think about what it's asking you. It's the area under the curve if you graph out 5 from B to A. How can you figure from A to B, excuse me. How can you figure out what that area under the curve is going to be? Let's ask this. What shape is it going to be? Hands up, please, when you can tell me. What shape, if we're collecting the area under the curve, is that second integral going to create? 1, 2 people. That's it. You did this last class. You absolutely did this last class. John, what do you say?
Rectangle.
It's going to make a rectangle. How high is the rectangle?
5.
How wide is it?
From A to B.
Yeah, so what's the width on it going to be?
A plus B.
Nope. B minus A, you take the upper number minus the lower one. So if I wanted to figure out what the area of that's going to be, it's 5 times B minus A. It's a rectangle. We did it the other day. What would you do to work towards an answer from here? Megan, what would your next step be? I got to do something before I combine like terms. Distribute. So I'm going to distribute out. Now I'm going to combine like terms, Megan. What are you going to be left with? Close. Take another look. What'd you say it's going to be? Maybe I misheard you. Negative 4a plus 7b. Which answer choice is that? Which one? How many out of the 3 you think they're going to email us? 1? All right. 0?
Wow.
I think so. That's what I think.
We have a lot of snakes in there.
Yeah. We'll find out who you are. Someone will say. Did you, John?
No.
I bet you did.
I'm just alive.
We'll subpoena the records. Now, take a look at this next one. It says this expression is a Riemann sum approximation for what? Now, this is one thing you have to keep in mind. Remember we did Riemann sums before. where that's when you're going through dividing it up into a different number of partitions. How many partitions am I dividing this up into? 50. I've got 50 little partitions that I'm dividing this up into. And what's the function going to look like when I go through and do this out? Well, if you're taking a Riemann sum, that means you're creating a bunch of rectangles. So 1 over 50 is going to be the height, or sorry, the width of them. And then to figure out the height, these are all the function values. The width on all the Riemann rectangles is going to be constant, how far apart, how wide they are. The going up is what varies. Now when I do this out, I start at 1 over 50 and I go to 50 over 50. Which of these does that represent? Which integral is the collection of Riemann sums, a bunch of them, going across? Who's got an idea on which one you think it's going to be? This was a non-calculator question. You're collecting a bunch of Riemann sums. Which one do you think it's going to be? We got 1, 2. Adam? It's not going to be E because of that 50 that's there. No. Because of, keep in mind, where does this start? Remember, you get what the constraints are from the inputs. One of them I start off and I put in my input as 1 over 50, and I keep going until I get to 50 over 50. So it has to end at what? 1. And it's got to start at 0. Which one are you thinking?
B.
It's going to be B. Because what you're doing is you're taking that area of the radical and then taking 1/50th of it. Now, here's what that looks like. You have your homework. Do day 4s get done up to day 4's homework? If more needs to be sent out to you, I will. I'm also going to send out the last example for today. I'm going to send this out to you on how to go through and get it. Okay? No questions ever in here.
It's really bad.